So hello, we are going to start where we left in previous class. It is 10 obstacle and opportunities. We'll discuss in detail availability of service, data login, data confidentiality and auditability, data transfer bottleneck, performance unpredictability, scalable storage, bugs in large scale distributed systems, scaling quickly, reputation fate sharing, license, software licensing. This de- content was taken from NIST definitions of cloud computing that was being published by NIST, National Institute of Standards and Technology. So what is availability of service? So availability of service basically mean that how successful you are in terms of having multiple point of failure. Means if you have a single point of failure, then if a company go that point or server or data center goes down, then there will be a significant problem. But you need to, as an engineer, you need to have a cluster node or multiple data centers that would not have any single source of failure. So no single source of failure is important for you to design a cloud computing. Then what is company may even go out of business if you are using some cloud vendor. That cloud vendor goes out of business and it stopped providing service. For example, Orkut has gone out of social media. So they given time for their users to download their images or data that they have uploaded on Orkut. Then that's why you need to have multiple data center or multiple companies for depending, and you can have different regions for doing this kind of work. Thus, some cloud vendors must fulfill some business continuity and strategic agreement in such conditions. So we are expecting cloud vendor to have a specific goal and a specific strategy and to meet out all the agreement. Then distributed denial of service is one of the uh, problem in availability of service. So what happened? DDoS attack happens, which actually compromises some uh, activities and it targets a single point, and because of that the other users, all the users get suffered because of denial of service. So what happens? Multiple requests are being communicated by attacker, and that actually creates denial of service. There is a problem of data lock-in with cloud computing. So what happens? Some customers are not able to extract their data and program, and there are no single program that could help to shift data from one site to another site or one cloud to another cloud. So what happens? It creates difficulty in extraction of data and thus preventing some of the organization to adopt cloud computing. Then what happens? Some online storage service, if it gets shut down, means it stops providing you service, then what happens? You will lose your data if you kept your data on a company which stopped working. So you will lose the access over that data. For example, what happened? FIFA 21, EA Sports FIFA 21 has been transferred from FIFA 21 to FIFA 22. So there are various players that I had, like Messi, I have Ronaldinho, I have many other top players like Mbappe. So what happened when it moved from FIFA 21 to FIFA 22? I lost these football players for playing in the next version. So this is one of the disadvantage, and you lose some specific data. So they have their own policy, and this has happened with all the gamers in the world. So this is one of the example what is called data lock-in, and computing company like EA Sports decide to do some uh, shift and some changes and some versioning upgradation. So they can't make 100% upgradation of your data to another version. So you might lose that data. And what are the solution? Solution are that some standard APIs are needed to be developed. So the SaaS developer could deploy their service and data across. So standard API are one of the solution that will allow your data to transfer from one version to another version or one cloud to another cloud. You put your data, another solution is that you put your data on multiple cloud provider. So if there's one company which get failed, you will not have to worry about that failure, and you can always download a copy from another cloud provider. Then the solution will be result in redundancy and cloud pricing. And so these are the issues which actually creates me, means you need to pay extra for two different cloud provider. Then some issues happens like quality of service over price. So you tries to have get inclined toward quality of service rather than some price issues. Then standard APIs will actually result in the same software in the private cloud or in the public cloud. So there are some APIs that we'll study in Eucalyptus and Amazon. There are some APIs which actually connect your private cloud of Eucalyptus along with AWS, Amazon Web Service. So there are such APIs as well to connect private and public cloud. Then data confidentiality and auditing. So what happens? Some organizations are having sensitive data, and they rarely use cloud computing for that. So what happens? They actually encrypt those data and stores those data if they want to store in cloud computing. So first they encrypt and they store it on cloud. Otherwise, they would have a virtual local area network for their own data management. They will have network middle box like firewall, packet transfer. So, how many of you know that firewalls are actually blade servers or servers? So these servers actually have pre-installed coding of security, and these were kept in the server uh, at server and data center. And whenever some request comes in or goes out, so these firewalls are the first interact, and thereafter you can have the uh, packet transfer. Then you have auditability at various layers, and you can have one layer as for auditing. So you have additional layer for auditing, and additional effort are required for auditing. There are many nations have different rules, and they require different software as a service provider to keep the customers data and copyright material within national boundaries. So there are various laws, various legal agreements by a government or organization with SaaS provider, and they keep the customer data and copyright material within those boundaries, whether it's of company or it's of nation. Then some business may not like the ability of country to get access to their data. What happened? Some businesses are like very highly data intensive, security intensive, data intensive. They do not like a country to access those data. Means country have a specific power, so the country could forcefully access those data, but these companies are not willing to access those data. For example, Twitter wants to continue with some of the tweets that governments, Indian government don't like, and there are various tweets which were being removed forcefully by Indian government. So these are the some business and government issues with particular country. For example, Twitter or such social media does not work in China. So these are the issues. Then European customers are very sensitive towards data and they don't like software as a service in United States to access those data. So this is an example, very famous example that European citizens are very sensitive towards their data. None like Indians. Indians are free to upload their data on social media and they don't care. But Europeans do care about all these things. Flexibility to place the storage. So what happens? There are various lock-ins, data lock-ins as we discussed. So it's very hard to get flexibility, but everybody wants to prefer flexibility to store data at various locations. Then Amazon allowing provider to keep data in whichever they choose physically in United States or Europe. So this example says that Amazon had created data centers in both the places in United States as well as in Europe. So the Europeans could choose to store their data in Europe if they want. So physically storage are being devised by Amazon. So these are the examples that could be possible. And this gives flexibility of storage. So and next, data transfer bottleneck. Data transfer bottleneck means there are some data intensive application. Data placements and data transportation across the cloud are one of the major challenges in cloud computing. Means you have a significantly large data, thousands of terabyte data. So what you'll do, if you start transferring it through network, then it will take too much time. Why? Because data transfer cost is also important. What is data transfer cost? Mainly it is the bandwidth that you purchase, and secondly, the time that it will take. So even if we have enough money for purchasing the bandwidth, but time is one of the factor which none of the country or none of the company or none of the cloud vendor could purchase. Time is a in means precious asset. It can't be purchased. So start thinking about this numerical. So in this numerical, what happens? There's a high cost of transfer of data. So internet transfer cost is very high, and thus they prefer and they choose to transfer that data through physical medium. How they choose means there are cars or trucks or any other automobile or any international continental transfer, then aeroplanes or shipments are there to transfer such data. So what they do, they transfer it through physical medium by bus, car, truck, airways, like that, trains, etc. So this numerical will explain you why. Suppose if you want to transfer only 10 terabytes of data from X to Y, we are not talking about thousands of terabytes, just 10 terabytes from X to Y. Suppose a measured average bandwidth is of 20 megabits per second. So you will think that this average bandwidth is low, but it is a case when you have to transfer it from one city to another city. Suppose from Hyderabad to Bangalore, you have to transfer. Then you'll get only 20 megabits per second, like such speed. Then what happened? It would take what amount of time? So when you calculate it as a numerical, 10 cross 10 to the power 12 bytes divided by 20 cross 10 to the power 6 bits per second, and that will having this large amount of 4,000 seconds. So it's around 45 plus days it will cost. So it will take huge amount of time. Then it is very high network transfer fees to pay, 45 plus days. For traveling from Hyderabad to Bangalore, it takes only maximum with the physical transfer of that data to unloading to offloading that data. It will take maximum 1 day if you take truck or some other cars to transfer that data. So it is worthless to wait for 45 days to get transfer over the network. Then you have data transfer bottleneck. How? There are various bottlenecks happens in data transferring. As we had just discussed, the transfer cost is very high, but there are some issues also when there are some bottleneck. So in what conditions the these data transfer bottleneck happens? So these bottleneck happens because of putting some large data in the cloud. Provider needs to purchase large amount of cloud computing cycles, and this actually reduces bottlenecks. When you have to put, these are the examples when you need to face the bottlenecks, like large host public data set. There is very large size of data set. So for example, free census data, images, data set that attracts customers to purchase some cloud computing cycles. In such condition, you will think for it's fine to have bottleneck. But for example, in Google Images, so you download, keep on downloading Google Images from Google Image Service. So this is fine, and Google could able to manage, but you can't able to download thousands of image in a one go, one shot. It will take time. Means it will have what you that images are being zipped out into some rar file or some zipping would be done, and then when you download it you can unzip it. So what happens, the cloud computing, why they do so image data storage would actually attracts customer of Google, so it's better to afford such things. For backup service, suppose if a company have large amount of data and they have more data to send as compared to they have to receive, so company have to send more data as compared to they have to receive. So what happens, in weekend they can move full backup by shipping physical disk. So what they do in the weekend, Saturday Sunday, they have a copy of a data of the data, and the large amount they download it and they put it on the uh, on some disk, and they shift it by physical disk transfer shipping through car and truck. Then for achievement uh, of getting data and that are required to be archived, so some archiving of the data needed to be done, and for that you need to purchase some of the cloud computing cycle as a customer. So they actually likes Google or other companies if you do the archiving of the data. Then that creates a search index, and that would actually help you to find the images. And you can find out image recognition could work on the archived photo if you wish to do the archive. So that is beneficial for uh, and that reduces some of the cloud computing cycle. Then performance and predictability. So some of the condition is like sharing some of the CPU and memory through virtual machines. That can be done very easily, but the problem happens when you have to share input output efficiently. Then input output is costly, time costly. So you need to wait for input to work and output to work. And sharing CPU and memory, it's easy through virtual machine, but sharing input output is really tricky. So what happens? Sometimes uh, team virtual teams could work together, and they have to access a server or some machine remotely. So it takes very too much time to do the graphic processing, means the image of that desktop and the mouse movement or the input text you have to place. So that takes time, text or mouse cursor movement and the image that it comes. So that actually takes time. But the server which is working in the backend or machine that you are accessing remotely would work fine. Means CPU sharing and memory would work fine in such case. But IO is the costly performance that need to be measured. Then scope of improvement is in interrupt and IO management. So as I told you that there is a chance of improvement of productivity when you have better interrupt, means cursor movement and putting some data, shifting the data to s- remote machine, and you have want output from that remote machine. So that improvement could be possible. So how it could be done? When you will use flash memory, means semiconductor memory, then it will work little faster. Thereafter, what are the scope of improvement in the batch processing at virtual machine? So you could have uh, start a batch processing in the remote server, and you just forget about it. It will take five 1 hour 5 minutes or something like that, and your work has been done after that time. So batch processing could be one way at such virtual machine. Then scope of implementation like visual process, cloud process monitor. So scope of improvement could be there that can show the multiple thread running concurrently at the program. These are the scope of improvement possible in cloud computing. And scalable storage, how to apply for short-term usage, and you don't have to worry about upfront cost, and there are infinite capacity of on demand, and that would help you to the persistent storage. What does it mean? It means that scalable storage could be done when you have short term usage. For very short term you can have usage, and you have very less, no upfront cost, low and no upfront cost could be there. Then you have infinite capacity on demand for such persistent storage. So this is what it meant by scalable storage. Short-term usage, no upfront cost, infinite capacity, on-demand usage. So then what is that? Varying in the richness of query and storage API. So are various APIs that could help you to storage and query processing efficiently. So there are lots of research going on how to make an API more efficient to access some data and to store that data. Then performance guarantees are needed for such scalable storage. complexity of data structure also needs to be measured, and directly support system should need to work out in such storage system. Schema less blobs are there, column oriented storage are there. So such complexity of data structure also matters, and that actually directly supports such storage system. Then create a storage system would actually not only meet these needs. So then you combine what cloud uh, at the scalable and up and down could be done at on demand basis, and thus you meet a programmer's expectation for the resource management. So what it means, you need to make efficient APIs, you need to make combined cloud advantage with up and down of on demand. Means there's sometimes very large usage, so up cost is there, and there are very low usage, so down cost are there. Means you have very low cost to pay. So these are the expectation of programmers. These the programmers have to manage all these things for the resource management, for scalability, durability, and high availability. Then bugs in the large scale distributed system. Suppose you are dealing with large scale distributed system is established by Hadoop, Spark like computing platform. What happens? There are various bugs in such complex cloud computing model, and what happens? You need to manage and debug those errors. So it's very difficult sometimes to removing such errors, and for specifically for the very large scale distributed system. So these bugs are not easily reproducible or configurable as a simulator. So they happens at the real time at live when you are running and your customer is using. So these bugs happens, and sometimes it takes very large time to do debugging at the data center. So these are the challenges of bugs in the large scale distributed system. Then quickly scaling. What does it mean by scaling quickly? Means pay as you go model. Suddenly your customers are been increasing. So certainly you need to use more amount of CPU. Your customer need to use more amount of CPU, storage, network bandwidth. So your company, cloud computing company, should have to be capable enough to provide a scalable, quick scalability. Then scaling in response to load increase and decrease. So sometimes load increases, number of user increases, and sometimes user decreases. And with that, all these increase and decrease, your service level agreement should not be violated. So your company, cloud computing vendor, should have to promise and continue service level agreement, whether it is increasing of demand of your server or decrease in the number of customers or users. For example, what happens? Google App Engine would actually provide such better service level agreement, and they actually charges based upon CPU cycles. Amazon basically charges based upon hourly hours of instance and number of instances that you are using of some images, virtual machines. Then there are various reasons for doing scaling to conserve these resources, and some amount of money is being uh, become productive because it is pay as you go model. Then idle computers between the two or third of the part power could be busy. So what happens? Some of the idle computers are there, and they could be become useful if they are being connected to the cluster or server. Thus, it will optimize the idle computers and can reduce data center cost. So it's having less chance of staying some of the computer idle. Then programmers need to pay attention to efficient processing. So these are the programmers' tasks to provide quick scaling. And there are some sometimes it's better to leave machine idle overnight to avoid reconfiguring the work next day. So what happens if you configured a Hadoop distributed system in 2 3 4 machines? It is better to keep those machines running as idle, and they'll not cost you much as compared to you come another day and starts the Hadoop server again, and probably if you need to reconfigure that Hadoop server next day as well. So that reconfiguration cost could be avoided. Reputation feed sharing. So what happens? Some customer behaves very badly. So bad behavior of those customer actually affects the reputation of cloud. And what happens in some of the case, reputation guarding services are there. For example, the best example that you see is trusted email service. What happens? Many different companies create accounts on gmail.com. So these company creates gmail account.com and they start mailing and phishing the all the and flooding these advertisement email or some rumors or some uh, fake information or some avoid unethical or something. They keep on pushing those emails. So Gmail is not responsible for that. The company which created that email address is responsible. So for that, spam is the way to control it. So it can only allow this Google server only allow trusted email to work out. So companies sending the spam should be reliable for all these spams, not the cloud vendor. So Gmail is not the reliable for that, but Gmail have to stop these spam mails and push these spam mail automatically to spam, and these are the service. Then software licensing are there. Like you have heard about software licenses are required. Similarly, some cloud provider provides some software based upon commercial licenses. So there are various softwares which are open source dependent, but still open source licenses have some models and they have some flexibility as compared to some commercial licenses. So it is preferred to use open source software and not to prefer some proprietary software. So you don't have to worry about licenses. So open source software are better than commercial software. So license actually changes and they need some open source or some commercial software to remain popular in the cloud. So there are various licenses and there are like like uh, uh, MIT license are there, like various software licensing are there. They are also applicable to the cloud computing as well. Cloud licensing are like GPL license are there, like MIT license are there, like common copyright license are there. There are various creative common license are there. So these are the kind of license which also works in cloud computing. And then next, there are suppose there are two companies that collaborate with each other on the pay as you go model. Then software licensing would be done between these two cloud companies for accessing those cloud. So these are the basically opportunities in cloud computing. So it is written obstacle and opportunities. So it is summarization of what we had discussed today. 1, 3 and 1, 2, 3 are basically technical obstacles to adopting cloud computing. Availability of service, data login, data confidentiality and auditability. So programmers are needed for handling these three things. How it could be, what is the opportunity? Multiple cloud providers, then elasticity and defending some kind of attacks. There are various standard APIs should need to be done. There are various compatibility of software need to be managed. Then various encryptions could be possible, firewalls could be possible, national law or geographical data storage are needed. Then next, 4, 5, 6, 7, 8 are basically technical obstacle when it is required to evolving the cloud computing. Means when there is a growth of cloud computing model, then these 4, 5, 6 and 7 happens. So you had already developed a cloud computing environment and you are using or your company is providing. So what happens? Data transfer bottleneck happens with you. So disk transfer is required, high bandwidth are required, and then performance and predictability happens. Virtual machine needs support, flash memory should be better, virtual machines to be managed. Then scalable storage means you need to invent some scalable storage. Then bugs are there in the large scale distributed system where you need some debugger to rely upon at the distributed version of virtual machine. Then in 9 and 10, what happened? Reputation feed sharing and software licensing. So in this, policy and business obstacles are there. And policy and business obstacles are there for the adoption of cloud computing. What happens? These are non-technical and policy and business, legal and management related issues are there, like in reputation feed sharing, where reputation guarding service are required, for example in spamming email. Then software licensing means how much budget you have, what pay for the license, bulk of usage could be managed. So these two are ending two are legal and management related policy and business arguments. So whatever we discuss in this part, we concluded. So we had discussed how technology works and how cloud computing has been evolved. Thereafter, we had seen what are the strength of hardware that are required, what are the impact of new distributed computing that are required, different cloud computing type like private, public, and hybrid community clouds are there. Some risk we had discussed, some security and privacy risk involved. Then we had seen various cloud services available in public. We had also discussed and introduced application layer software as a service. We had discussed. We had discussed about regulatory issues with their limitations. What are the regulatory issues in cloud computing? Then we had discussed about what are the obstacles as well as their opportunities in those obstacles. So that's it. These are the references. You can go and read these references in detail. So thanks a lot. I hope that you find this part as interesting.
Thank you, sir.
Thanks. Any
Sir,
question or any doubt?
yes, sir. Sir, can you please mm, list all the requirements of the project on the classroom?
Yes, sure. I'll list all these requirements and I'll share a form, Google form, in which your team has to upload their names and title of the project and abstract of the project. And thereafter, in the end semester, you will get a chance to upload PDF for evaluation of write-up, that how much content, technical content you did, what is the quality of presentation you provide, then what is the technical content you have and how you present it, what is your verbal communication in that project. So the better you know, more depth you know of that project, better you speak, better you present, better you write. So that's the whole purpose. And it means that you create your own question, you write your own answer. I'll judge the level of question that you had created, I'll judge the level of answer that you had provided. So what is the hardness of that problem that you are facing in the project is being evaluated, and what is the approach and how you had solved it, and how did you presented that solution and that project problem. So this is the way the project will be evaluated in the whole semester. Thanks. Any other question? Okay, so we'll stop here. We'll meet in next class. Bye.